In the year 1492, an Italian captain and explorer named Christopher Columbus, using the maps of his time, calculated that Japan was 7,000 kilometers west of Spain. Based on these calculations, he made plans and set sail westward from Spain. He was charting a new course to East Asia. On the morning of October 12, 1492, Columbus's ships encountered an unknown land. Through Columbus's eyes, Rodrigo saw an island, one of the 3 Spanish ships, and exclaimed, "Land ho!" He had spotted an island now known as the Bahamas, and land was in sight. Columbus arrived at an area we now call the Indonesian archipelago, still unaware that in reality, East Asia was not 7,000 kilometers, but 20,000 kilometers west of Spain. Between these 2 points lay 2 entirely unknown continents. Despite this groundbreaking discovery, Christopher Columbus couldn't think differently. He couldn't accept his ignorance, and he clung to his mistake until the end of his life. For many people living in that era, it was inconceivable that he had discovered an entirely new continent. Great thinkers, scholars, and infallible sacred texts had only mentioned Europe, Africa, and Asia for thousands of years. It was impossible for anything else to exist alongside them. Another Italian sailor named Amerigo Vespucci, between 1499 and 1504, visited the newly discovered lands by Columbus multiple times. He believed that these were not islands in the waters of East Asia but entirely new territories unknown to ancient geographers and current Europeans. He published 2 texts about his travels in Europe in 1502 and 1504. In 1520, the German cartographer Martin Waldseemüller, convinced by these claims, published an updated world map. This map showed, for the first time, the presence of a separate continent in the west of Europe. Naturally, this new land needed names on the map, and it was thought that the one who discovered it was Amerigo Vespucci. In his honor, they named the new continent America. Thus, ironically, the continent was not named after the explorer Columbus, but after Vespucci, who was much more willing to admit the truth. The map of the new continent became very popular and was copied by many of his friends. This is how the continent got its name. As you can appreciate, even before the modern era, many cultures had made maps. None of these maps knew the entire world, but despite this, you won't find any empty spaces on the maps. They all gave the impression that they knew the world very well. But in reality, no African or Asian culture knew America, and no American culture knew Africa or Asia. That's why, my friends, the discovery of America is at the heart of the scientific revolution. Because this discovery taught Europeans that current observations were more accurate than ancient traditions. It also fueled their desire to reach new knowledge with an eagerness to conquer America. To control these vast territories, Europeans needed to gather an extraordinary amount of data about their geography, climate, fauna, languages, cultures, and history. Religious texts, ancient geography books, and traditions were of no use. From that moment on, both European geographers and researchers from every field began to make maps with gaps to be filled in later. This way, they admitted that they were not perfect and were willing to correct their tools. In fact, Europeans in the early modern era were not the first and only community to explore the world. But what set them apart from other nations was that, just like a magnet attracts, they were drawn to the gaps on the map and gradually filled them with advancements. Throughout the 15th and 16th centuries, they sailed around Africa, discovered America, and opened up the Pacific and Indian Oceans, creating a global issue that concerned the entire world. Thus, they established the first truly global empires and the first global trade network. The imperial expeditions of Europe changed world history. History had come to a point where it was not a disjointed series of peoples and cultures but the history of a single integrated human society. We will return to the new age when the scientific revolution took place, but now I want to take you back to the ancient age, which I call the first T name, my friends. Because to better understand the scientific revolution, we also need to look at how science was born. Now, I want you to imagine that you are an ancient person who lived thousands of years ago. You are looking at the sky, and suddenly, a very powerful thing appears in the cloudy sky. A group of them makes a deafening sound, and you want to hear it. You have no knowledge about what electricity is or what an electron means. You have no idea about the electromagnetic relationship among the clouds. You don't even know where the rainwater comes from in the sky. Like everyone else, you would think the most reasonable explanation would be that some supernatural power, much stronger and powerful than you, could have caused this. For example, this supernatural power might be angry with people and could manifest these lightning strikes as a warning. Lightning could be sent as a punishment to humans. Or, we could say that the angry gods above are fighting. And thinking this way would be perfectly reasonable. Some philosophers who lived in ancient Greece thought that this might not be the case. They tried to explain such natural events by developing theories rather than resorting to myths. For example, Anaximander hypothesized that thunder, lightning, and hurricanes occurred due to wind movement. According to him, whenever wind was trapped inside a dense cloud and forced its way out, this forward movement caused a sound due to the lightness of the wind, and the crack in the cloud that appeared in the black of the cloud caused a lightning strike. Anaximander's hypothesis was not an explanation of natural events in the sense of godly movements, but rather an attempt to provide a natural explanation to an alleged phenomenon. However, even before these philosophers, it was believed that Zeus was responsible for thunder and Poseidon for earthquakes. Well, here it is. What exactly separates philosophers from the common folk, my friends, is this. Anaximander as well. Well, he could have considered the explanation that the gods were the cause of these. In such a case, there would be no need to develop a theory, everything was already quite understandable. But he did not opt for this simple and effortless explanation. It wasn't 12,000 that it happened. It wouldn't be wrong to say that ancient Greece, especially the Ionian Greeks, was the birthplace of where science emerged. Even more specifically, it would be more accurate to say that it was born in Miletus, which is located within the borders of Aydın province in present-day Turkey. Of course, we shouldn't underestimate the contributions of earlier civilizations, but still, it was primarily the Ionian philosophers who transformed knowledge by benefiting from the technologies of other cultures, especially the Babylonians and the Egyptians. So why didn't other societies adopt this questioning perspective and develop theories? What set apart ancient Greek society, or what made the ancient Greeks different? The ancient Greeks had something that no society before them had. They were the first to make a distinction between science and technology. For instance, a person could treat an illness using practical methods with the help of technological tools. However, this didn't mean that they still possessed the ability to explain the reason behind what they did, the reason why something was happening. This is where science came into play. Secondly, Greek society was quite different from other ancient societies in terms of its hierarchical organization and its focus on an official religion. Thirdly, it was multicultural and had a democratic state structure. Fourthly, in ancient Greek society, there was a dominant tolerance for debates, and wealthy individuals had the leisure to contemplate philosophical and scientific matters. Other societies did not have these factors. For instance, the Babylonians, who lived in Mesopotamia, had some effective methods to treat diseases and had some knowledge about the human body. However, no matter how good their treatment methods were, they still did not attribute the disease to physical causes or connect these problems to them. Instead, they saw the disease as a punishment given by the gods in response to a committed sin. Therefore, the first task of a doctor was to diagnose the sin, and then apply the necessary purification method to seek forgiveness. The approach of the Babylonian physicians was quite the opposite of the approach of Hippocrates, who embraced the ideas of the Greek Hippocratic school. Now, let's take a closer look at this issue, my friends. Hippocrates, known as the father of medicine, and the community of followers he formed, asserted that no disease occurred due to the intervention of gods, and that every disease had a physical, natural cause. Epilepsy, which the Greeks referred to as the sacred disease, and considered it differently from other diseases, was treated in the same manner. Up until then, such mysterious diseases were seen as possession by demons, witchcraft, or as the work of gods entering the body. But Hippocratic doctors had taken away the work of malignant demons and sorcerers with their explanations. In the introduction to their work titled On the Sacred Disease, they had this to say: so-called sacred disease is not more sacred or divine than other diseases, because like others, it originates from natural causes, and the ignorance and wonder that make people consider it divine or distinct from others are due to inexperience. When you examine the head of a person with the same disease, you will see that the brain is wet and filled with fluid. This is an indication that it is a disease, not a punishment inflicted by gods causing harm to the body. Yes, up to this point, we discussed how to better understand the scientific revolution. We talked about how science was born. We didn't touch on all the ancient Greek philosophers. For instance, Lucretius, who was the first to propose the idea of atoms, and Democritus, or when we think of mathematics, Pythagoras and Euclid. Many thinkers can be mentioned, but generally speaking, even though they were influenced by Eastern philosophies, it wouldn't be wrong to say that science was born in ancient Greece. Because, even though the theories they put forward were rough, they were scientific theories rather than myths. Of course, many of the theories they developed were erroneous. But the important point here was that they had started to separate cosmology from theology. My aim here is not to talk about all these philosophers, but rather to be able to explain, even if slightly, how science was born. Now, let's take a closer look at celestial thoughts in the process leading up to the scientific revolution. These ancient societies were also puzzled about why objects fall down when dropped. Previously, the idea prevalent in Greece was that objects fell from the highest point of the house to the lowest point in a straight line. However, this seemingly energetic world raised the question of why the lower part of the universe did not fall to the earth. Such a cosmology required something that supported and held the earth. Aristotle looked at the matter from a different perspective. He developed a geocentric theory, positioning the earth at the center of the universe, with heavy objects also moving towards the earth. This way, the problem of the earth falling was overcome because any heavy object moved towards the center of the universe, which was itself. Therefore, the earth could remain stationary. In ancient Greece, the idea that the earth was stationary and at the center was dominant. Additionally, the Greeks had enough reasons to support these ideas. Today, we know that the earth has two fundamental motions: one is its daily rotation around its own axis, and the other is its yearly revolution around the sun. However, if the earth were in motion, noticeable consequences would have to arise. This led to questions such as, if the earth rotates from west to east daily, why isn't there a continuous wind from east to west? Or, if the earth orbits around the sun, how do objects and living beings stay attached to the earth's surface? Why doesn't the earth break apart and go away, or why does the moon follow the earth? Today, we can answer these questions with physical laws and the force of gravity. We know that the earth carries its atmosphere along with itself. However, Greek science could not provide such answers. Another question was this: if the earth were orbiting the sun, wouldn't the positions of the stars change significantly relative to the earth? When the earth covers such a long distance, shouldn't the stars appear different when on one side compared to when on the other side? Actually, we know that this is exactly the case today, but our knowledge is made possible by modern scientific instruments, only available since 1838. This is because the stars are so far away from the earth that the parallax of the stars is too small to be seen with the naked eye. Yet, it was not possible for the Greeks to observe this. In their view, the stars were all at equal distances and even slightly beyond Saturn, the farthest visible planet, along a line. The universe designed by the Greeks was not larger than our current solar system. According to them, if the earth revolved around the sun, the stars should be visibly different because they would appear brighter. If parallax was not observed in the stars, the conclusion was clear: the earth was not moving. In fact, there was even an astronomer in ancient Greece who believed that the earth orbited the sun, named Aristarchus. However, no one paid attention to his thoughts in the ancient world, and at that time, with their limited knowledge, it's not surprising that the Greeks embraced the idea that the Earth was at the center and stationary. So far, we've talked about how science emerged in ancient Greece, but after the fall of the Roman Empire, we must not forget the role of Arab Islamic culture, which played a significant role in preserving, spreading, and transforming Greek science. The scientific understanding that emerged in Islamic culture later advanced to the West, pulling it out of the Dark Ages and leading it to the Renaissance and the scientific revolution. With this additional information provided, we can return to celestial thoughts. There was no field of physics at the time, so the theory encountered many problems. Moreover, this theory lacked observational evidence to support it. The consolidation of Copernicus's theory only occurred after the work of Kepler and Galileo. Kepler discovered that the orbits of planets were elliptical, but it still faced some physical problems. It wasn't until after Galileo's observational evidence that Copernicus's theory gained firm ground. For the first time in history, in 1610, the person who turned a newly invented telescope towards the sky revealed that the Earth was not at the center. Nearly 2,000 years later, what we know about the Earth is being rewritten. Throughout history, people have always grappled with ignorance. But the real problem is that they were not aware of their ignorance. For example, until the scientific revolution, people knew nothing about microorganisms, which make up 99.99% of organisms on the planet. Yet, our bodies house an army of microorganisms, some of which are quite beneficial and indispensable, while others can make us sick. It's astounding that the human eye first beheld a microorganism in 1674, when Anton van Leeuwenhoek, with his homemade microscope, looked at a drop of water and discovered a world teeming with tiny creatures. Over the next 3 centuries, people became acquainted with a diverse array of microscopic beings, putting them to work for medicine and industry. Today, by manipulating bacteria, we can produce drugs and biofuels, and we can even eradicate parasites. On another note, perhaps the most significant event of the past 5 centuries took place at 5:29:45 a.m. on July 16, 1945, when American scientists detonated the first atomic bomb at Alamogordo, New Mexico. From that moment on, humanity not only had the power to alter the course of history, but also to bring it to an end. Another significant event occurred on July 20, 1969, when, for the first time in history, a human being set foot on the moon. This was not only a remarkable achievement, but an evolutionary and even cosmic one. In the previous 4 billion years of Earth's history, no organism had managed to leave the planet's atmosphere, let alone reach the lunar surface. So, how did modern science accomplish all of this? Humans have been attempting to understand the universe for at least as long as there has been a written history. Our ancestors devoted serious time and effort to studying the laws of nature. However, modern science differs from all preceding traditions in 3 important ways. Firstly, modern science acknowledges our ignorance and accepts that if we don't know something, it's even more important to recognize that what we think we know might turn out to be incorrect over time. No concept, idea, or theory is sacred and exempt from criticism. Secondly, model-based science aims to obtain new knowledge by valuing observation, experimentation, and mathematics, and it transforms collected information into comprehensive theories. Thirdly, modern science uses the theories it produces to acquire new powers and develop new technologies. In other words, the scientific revolution was, above all else, an age of ignorance. It was a time when people discovered that they didn't know the answers to the most important questions. Pre-modern knowledge traditions claimed that everything about the world was already known. Great gods, prophets, and wise men possessed knowledge that applied to everyone, and these were preserved for us in these ancient texts or handed down in writing. Ordinary mortals sought wisdom by studying these old texts and traditions and trying to understand them completely. Modern science, on the other hand, possesses its own unique knowledge. Because it knows that collective wisdom is subject to trade-offs concerning the most important questions. Darwin never claimed that he had completely and eternally solved the mystery of life. After centuries of intensive scientific research, biologists still admit that they don't have a good explanation for how the brain works. Physicists, on the other hand, still don't know how to reconcile the Big Bang experiment with the theory of general relativity or quantum mechanics. Certain theories are supported so strongly by existing evidence that all alternative theories are dismissed. Root offspring are generally accepted as correct, but everyone acknowledges that the theory will be reviewed if evidence against it emerges. While ancient thinkers often formulated theories with stories, modern science uses mathematics. For example, building. This allowed Isaac Newton, perhaps the most important figure in modern history, to publish the mathematical principles of natural philosophy. It was a book filled with drawings and formulas. With this book, Newton presented a general theory about motion and change. The greatness of Newton's theory was that, by using just 3 simple mathematical expressions, he could explain the motion of everything in the universe, from falling apples to orbiting stars. We know today that anyone trying to understand the motion of an object, be it a cannonball or a planet, can easily calculate the object's future state if they know its mass, the direction it's moving, and the force acting upon it. Plugging these numbers into Newton's equations is sufficient. This method still works flawlessly today. However, in the early 20th century, scientists made observations that didn't align with Newton's calculations. This led to the next revolution in physics, the theories of special and general relativity, and quantum mechanics. This upheaval, which extends from the shifting of roles from the domed world of the sun to our first steps on the moon, and even continues to this day, is what we call the scientific revolution. During this revolution, humanity allocated vast resources to scientific research. Up until the 16th century, states and the wealthy approached the acquisition of new medical, military, and economic powers with suspicion. They allocated resources not to acquire new skills through education and research, but rather to preserve existing ones. They supported priests, philosophers, and poets by giving them money to maintain the legitimacy of their rule and the sustainability of social order. They didn't have goals like inventing new drugs, creating new weapons, or stimulating economic growth. However, over the past 5 centuries, people realized that they could gradually improve their skills through scientific research. This was not a blind bet, it had been empirically proven time and time again. As evidence for this increased, states and the wealthy began allocating more resources to science. Not investing in scientific research in the present day is akin to standing still. Because scientific research doesn't stop, the world is changing rapidly. States that couldn't keep up with these changes over the past few centuries have fallen. We can say that we are still in this process today, which may continue into the future. Throughout the past 5 centuries, scientific research has led to the acquisition of new powers. By the 16th century, states and the wealthy came to realize that this kind of investment could produce new medical, military, and economic powers. For example, the US government allocated billions of dollars to nuclear physics research in recent years. The knowledge produced by this research allowed the construction of nuclear power plants, providing cheap electricity for the American industry.